Well, students, we have finished discrete pricing models in the case of European style options. We will now discuss the pricing models for American options. As we considered in the European option, let us start with a financial market that consists of a single risky asset denoted by S on the discrete time levels. Script Tn is equal to T naught, which is 0, T1, T2, and so on till Tn, which is the expiration time, capital T. So we consider the probability space S. As usual, the sigma field is the power set of S and a probability measure, and also we will include the filtration that we generally consider Fn, which we discussed in one of the previous lecture. This is called a filtration probability space. So what it means, we have the probability space along with a filtration, that is a collection of sigma fields of information at every time level. Recall that this sequence of sigma fields have the following property. Fn1 is contained in Fn2 whenever N1 is less than or equal to N2. So this is what we have defined as filtration, and we have constructed this filtration in a particular way which is suitable for our finance problems. If you recall, we have done it in one of the classes, and this collection of objects, that is the sample space and probability together, gives you the probability space, and associated with this is a filtration. Okay, remember, your filtration at the time capital T is actually your F star, which you have taken here. This is nothing but the power set. Okay, so this is just a technicality you just have to keep in mind. So if you recall, the American option means what? It is an option in which the holder can exercise the option at any time tk prior to the expiration. Hence, the holder of the American option has two possibilities at every time level. What are they? Well, one is that the holder can choose to exercise the option at some time level, say Tk, in which case the holder obtains the payoff, which is given by this Hk, which depends on the price of the stock at that time, that is Sk, and that payoff is defined by maximum of 0, Sk minus k when it is a call option, where k is the strike, and in the case of put option it is maximum of 0, k minus sk. Therefore, the holder gets this payoff if he or she chooses to exercise the option at time t is equal to tk. Right? Now the next possibility is, obviously the holder may choose not to exercise the option at the time tk, in which case the option will be carried over to the next time level t equal to tk plus 1, right? So you have one of these two options that the holder can choose at the time t is equal to tk. If the holder chooses to exercise the option, then the situation is very clear. This holder will get the payoff, where the writer has to pay this payoff to the holder. Whereas if the holder chooses to hold the option and carry it over to the next time level, then we need to work little bit. Well, the idea in this case will be just similar to the European option, right? So you start from t equal to tk and you are going at least t equal to tk plus 1. Okay, in the next case. Therefore, the situation will be something similar to the European option as far as the time t equal to tk is concerned, because at that time the exercise did not happen. So this is the overall situation of an American option at every time level t equal to tk. Now, keeping this in mind, we have to adopt to an idea that gives a fair position for both the writer as well as the holder. right? So that was the main theme for us to develop the pricing model even in the European option case. The same thing we will be having as an underlying idea to develop the pricing model for the American option also. So how to arrive at this fair situation? Let us see. Just observe, if the holder doesn't exercise the option, then from Tk to Tk plus 1, the situation is similar to the one step backward technique discussed in the European option pricing model in the last section, where we have used the replicative and self-financing strategies and arrived at a fair price for the European option. The same idea we can follow here also. So at time t is equal to Tk, the holder did not exercise, therefore it is carried over to Tk plus 1. So assume that you know the value of the option at the time Tk plus 1. Remember, this can be a payoff if it is at the expiration. Otherwise, we have a way to get this hedge by using the replicative and the self-finance strategies. Here we will use a little different notation. We use HA K plus 1 for the value of the option at Tk plus 1, just to indicate that it is a American option. Recall that using this, we can obtain the value of these portfolio pi k, which is denoted by Vk at the time Tk, using the replicative and the self-finance strategies. The idea goes exactly same as in the European option, and we obtained Vk in terms of the conditional expectation given like this. Recall that this is your value at t is equal to Tk plus 1. Okay, if you remember, we obtained similarly Vk plus 1 at the time Tk plus 1, and then using the no arbitrage argument, you will say that the value of the portfolio, that is the replicative portfolio, is same as the value of the option as well. That is how we have arrived at the value of the option. This is value of the option at Tk plus 1. Here we just use a extra notation A in order to just mention that it is a American option. That's all. So otherwise, we know how to obtain this expression. We also know how this expression is given. So generally we put a star here and we don't mention this. Both are the same notations. So let's go on. Once you have this, let us see how to arrive at a fair price for the option at the time t equal to Tk. So we have to follow a kind of hedging strategy. Look at the writer's point of view. At the time t equal to Tk, writer has to either pay the payoff, which is denoted by Hk, right? If the option is exercised, or he has to maintain the cash Vk in order to face the situations at the later time level t equal to Tk plus 1. That is what the meaning of this. Again, I'll repeat. From the writer's point of view, a hedging situation is that the writer should have either the cash whose value is Hk if the holder exercises the option, or the writer should have the cash whose value is given by Vk in order to face the situation of exercising the option in the next time level. Okay, so the fair price that the writer should charge from the holder is the maximum of these two. So that's the hedging strategy from the writer's point of view, and this will also make a fair position for the holder as well. Therefore, we define the price of the American option at the time level t equal to Tk as the following, where at the expiration, the holder has no choice other than exercising the option. Therefore, the value is exactly the same as the payoff. On the other hand, at any intermediate time level, t equal to 0 to n minus 1, remember, you can also in fact include the time t equal to 0. Here, the price that has to be charged from the holder by the writer should be the maximum of the payoff and the value. In fact, with a no arbitrage argument, you can prove that this is the fair price that one can pay for the option at every time level tk. In particular, you can obtain the fair price for the option at the time level t equal to 0, which is the ultimate purpose of this model. The next interesting and important question is, what will be a suitable time for the holder to exercise the option? You can see that at every intermediate time level, you are taking the value of the option as this. In this, you can see that if HKA is equal to HK, that is the maximum is the payoff, then that time is a suitable time for the holder to exercise the option. So we will define the minimum exercise time as tau min is equal to minimum of the time in the time partition such that your HK, that is the payoff at that time, is greater than or equal to the value Vk of the replicative portfolio. Let us take an example. Consider an American put option which strike 1260 when the underlying asset is trading at 1267 per share. Let us take U as 1.01885 and D is equal to 0.971018. Also, let us take R is equal to 0.00132, and we take the time partition as T0, which is 0, T1 and T2. That is n is equal to 2 we will take. With this parameters U and D, you can see that the stock price process can be written in the lattice diagram as, so this is your S0 and this is your S0 U, which is also written as S1 1, and this is your S0 D, which is also written as S1 0, right? And similarly, this we have as S0 U U, which is S2 2, and this is your S0 UD, which is your S21, which is also SDU, and this is our S0 DD, which is S20, and similarly at time level. So this is the time level. T is equal to T1, and this is T2, and this is T3. Sorry, we have taken the time partition as T2 and T3, which is taken as capital T. So we have S3 comma 2, which is S0 UUU, and this is S3 1, which is equal to 2, which is S0 UUD, is S32 as well as, which is UDU. Sorry, this is this one, and this one is S31, which is equal to S0 U D, S0 D U, and this is also this, which is S31, which is equal to S0 DUD, and this is S30, which is S0 DDD, right? And then we can also give the payoff process in the lattice diagram as, remember, HK is in this case maximum of 0 comma K minus SK, right? And this is your H0, because H0 is 1260 minus 1267, which is minus 7, therefore it becomes 0. And this is your HK, that is H1 1, and this is your H10. You can just verify this. H22, this is H21, which is also H21, which goes via down and then up, and this is your H20. And finally, at the time level t equal to T3, you have H32, H31. This is also H31, and this is H30. Sorry, this is H33, not H32. And similarly, here it is S33 because it's S not U U U. Therefore, it is S3 3 here, not S32. Okay, please make this change. And so we have our payoff process in the form of lattice diagram is given like this. Now let us see how to obtain HA. Our aim is to obtain the value or the price of the option HA at every time level, which is denoted by HAK. For this, recall that we have to first start with the time level t is equal to T3. So at t equal to T3, we have HA3 is equal to H3. That is, you have all these values as they are from the payoff. Okay, so that implies your V2 can be written as 1 by 1 plus R into HA3, and you have first case is 3 and sorry, this is H32, not H31. So H33, H32, and then this is H31 and this is H30. So H33 means you went up, therefore its probability is P star plus HA3 means I'm writing for this, okay. 2 means at the last level you came down, therefore it is 1 minus P star. That gives me the value V2 at this level, right? So this level is computed using these two values. Therefore, that is V22 it is. That is 0. And what is V21? V21 is computed using these two values, and that is going to take this space. So it is 1 by 1 plus R into HA32. That is when you went up from this position. Therefore, it is P star plus H31 that you went from this position to 0. Therefore, you have 1 minus P star, and that gives me approximately equal to 15.69. And V20 is this, which you have to use these two. V20 is equal to 1 by 1 plus R into HA31, and that gives me the probability is P star plus H30, and that happens with probability 1 minus P star, and that is in my calculation approximately equal to 63.722. Let me put the calculations more clearly. Here is the payoff diagram, and this is the value process diagram. In that, we have calculated the time level T2, which gave us V2 like this. We have to find two more levels. Remember, at level T3, we don't find V. Therefore, this is just I have put it as 0. So once we get V2 at time level T is equal to T2, we have to find HA2. That is the value of the option at the time level t equal to 2. These are the values of the corresponding replicative portfolio. So how this H2A is given, if you recall, since it is in the intermediate time, it is given by maximum of the payoff at time level 2 and the value V2. So that gives us H22A to be maximum of H22 and V22, sorry, this is 2 here, and that is equal to maximum of H22 is 0, and similarly V22 is also 0, therefore it is 0 0 equal to 0, and H21A is maximum of H21 V21, where H21 is given by this, that is 6.5323 and 6, and V21 is given by this is 15.6906, and therefore it is 15.69 approximately. And what about H20A? And that is H20, that is 65.377, and here V20 is 63.722, and therefore it is 65.38 approximately. So we got the option value at t equal to T2. Now let us see how to get the option value at the time level t equal to T1. Again, in the same way, we have to find first what is V1, and from there we have to take the maximum among the payoff, and we want to get the option value. So you can see that so in the similar way as we did for V2, we can also find for V1. So this is your V1 comma 1, and this is your V1 comma 0, right? So that gives me H1A as H11 is equal to, it is the maximum between 0, that is this one, and 5744, that gives me 5.7441, and H10A is the maximum between 29.72 and 33.86, that gives me 33.86 approximately. Now once we have HA11 and HA10, we can find the value V0. V0 you can find with the help of this. Remember, it comes as a conditional expectation, and that gives us V0 as 16.0291, and from there we can find H0A, and that is equal to V0, and that is equal to 16.0291. Okay, so that's I mean, you have to take the maximum here. The payoff is 0, therefore you have 16.0291, and that is the required value of the option, which is also the price of the American put option at the time t equal to 0. So finally, you can write the option price process in the form of the lattice diagram like this. Let us now find the minimum exercise time for the option. If you recall, it is given by tau min is equal to minimum of all the times tk in the time partition Tn, such that the payoff is greater than or equal to the value, right? So in our case, you can see that let's go from t equal to 0 to capital T. The value at t equal to 0 is obtained as the maximum of the payoff and the value. You can see that the value was greater than the payoff. Therefore, t equal to 0 will not be the minimum exercise time. It means the holder will not prefer to exercise the option at t equal to 0. So he will carry over the position to T1. Let us see if the stock had gone up during this period, then your value would have been taken as the maximum between this value and this value. Again, you see the maximum is attained at the value and not at the payoff. Therefore, if the stock would have gone up in the first level, then the holder would not have exercised the option. Let's see if the stock went down in the first level, then again the payoff was 29.72. The corresponding value was 33.85. Therefore, your value of the option is achieved at the value of the replicative portfolio. Therefore, again, T equal to T1, none of the cases were favorable for the holder. Therefore, the holder would not have preferred to exercise the option at T equal to T1. Let us go to T equal to T2. Again, if the stock would have gone up twice from T equal to 0 to T equal to T2, then at T equal to T2, the value of the option is obtained from the maximum of these two values. Again, it is 0, so we don't need to worry about it. If it would have gone up in the first and then down in the second level, then you would have taken maximum among this and this one, that is 1569. That comes here from V. Therefore, again, in this case, the holder would not have preferred to exercise the option. Let us take the third case. It means from the level T equal to 0 till T equal to T2, the stock kept on going down, okay, and reached at T equal to T2, then the value of the option is the maximum between the payoff, that is 65.377, and the value of the replicative portfolio at level T equal to T2 in that case is 63.77. The maximum is achieved at the payoff, okay. Therefore, this is a good place for the holder to exercise the option. Therefore, it is T2 if your stock S2, that is the underlying asset, would have gone S0 DD, that is S2, 0, right? Which can also be written as S2, 0. So this is how you have to write. And further you go at time, of course, at the time level, if there was an intermediate time, then you will go again for the next level. But after T2, we have reached the expiration. Therefore, whatever may be the situation, the option will get exercised because it's an expiration. Therefore, you will write T otherwise. Okay, in certain cases, you may have this at more than one cases. So you have to list them all. Okay, say for instance at T1, if any one of this is achieved through the payoff, then that also you have to write T1 if S1 is something. And suppose it's a 4 level and T3 you got some cases, then you have to write T3 if S3 is something. Like that, you have to write the minimum time in that way.